So let's talk about the problem. And this isn't really a problem with STEM, but it's a problem with science, and I think a lot of you can relate. So the school I teach at, it's a Title I school. It serves mostly students from Camden City. Most of our students are on free and reduced lunch. Just by a show of hands, how many of you have heard of Camden City, New Jersey before? Oh, wow, a lot of people. Okay. So can you tell me when you think of Camden City, what is Camden known for, I guess? Or infamous for? What do we know? There is a university, there's a branch of Rutgers in Camden. Yes, this is true. What else? If you're anyone from New Jersey? Yes. So you know about Camden.
A little bit. It's pretty poor, pretty tough area.
Very tough area, right? So fun facts about Camden include on Wikipedia that in the past 10 years, it's been #1 in the most dangerous city in the United States 3 times. And since 1998, it hasn't dropped out of the top 10. So to say that my students are going home to a tough environment, that's a bit of an understatement. Okay, that's a bit of an understatement. And so one of my students put this very eloquent to me. This is a very bright student. He said, look, Mr. King, I respect you as a professional. I think you're a great teacher, but there's no way I'm doing this piece of homework when I go home. And here's why I'm not going to do your homework, okay? So here's my life, he says. I've got a girlfriend, so when I go home, I've got to talk to her. I've got to spend an hour or 2 hours doing that. Did you know that I'm close to becoming a Call of Duty professional? I'm in this clan, and if I just get a little bit better, I'm going to be like the top star of this clan. I'm going to be able to make videos. People are going to watch my videos on YouTube, and I'm just going to start rolling in the dough. All right, so I got that in my back pocket. And he's also a fan of TV shows, one of them Breaking Bad that I put on here. He says, I'm also a Facebook fiend. You can follow me on Twitter at so-and-so-and-so, and give me a call, Mr. King. I'd love to chat with you. Let's chill out, bro. Let's chill out. Give me a call. All right. So then he says, where does your homework fit into this, right? You've got a list of 10 problems that says balance these reactions. Come on, Mr. King. Really now, do you think that this problem is going to really fit anywhere in my thought process? And so he's telling me that he's got 4 priorities of things to do, and Call of Duty is #1. Maybe after the girlfriend. I'm not sure. Those are pretty close. But those are pretty close, and then your homework is like tier 4, and that's on a good day. Like if I'm having a good day and I am actually thinking about work, maybe you're the 4th thing on this list, all right? So I had to really find a way to engage them, and that's not even including everything that comes with Camden, right? That's not including anything that comes with Camden. So I'm like, all right, I've got to be a little bit more engaging. So how I think about this, I'm a chemist, so of course I'm going to go to what I know, and that's a reaction diagram, all right? This awesome reaction diagram. And here's how I think of learning. I think of learning as an energetically favorable reaction, okay? So this is the learning curve, so to speak. And when people learn, I think they feel good about learning. When I learn something, I feel good. And I believe all students also feel good when they learn. When they learn something, they're like, yes, I feel good about myself, right? What the problem is science is when I give them a sheet that says, okay, balance these 10 equations. All right, what I'm doing is I'm making this activation energy super duper high, right? It's like you have to put so much energy to figure out why this even matters to me. And then by the time they put in the energy, it's too steep of a hill for them to climb. All right, so the good thing is I've got an energetically favorable reaction. The problem is my activation energy is too high, and now I've got to be the real catalyst to make this work for the student. Okay, so that's my first thing, my first problem. And the second one, you've heard this a billion times, so I'm not going to harp into it too much, but chemistry is such an isolated topic, apart from biology and physics. And chemistry topics in particular, they're very isolated. So, they're not very realistic. So let me give you an example. Again, like any problem worth solving in this world does not require just solution knowledge. It doesn't require just equilibrium knowledge, and yet we teach it that way. We teach it like these are separate topics that students need to learn, and as a result, they don't really apply it. They don't see the concept behind it. And the second issue I have is this is a textbook. This is Zoomdall, and I grew up learning from Zoomdall. So I love Zoomdall. I love doing the problems in the back of the textbook, but I was a little bit weird back then, and I didn't have Call of Duty, I guess, so this was the best thing I could do. But look at Zoomdall, and you notice that if I'm a student and I'm looking at Zoomdall, and I'm just looking at this, and I'm like, oh yes, I'm so excited to learn chemistry because I really want to learn stoichiometry. That's going to be awesome this year. I'm super excited and stoked to learn stoichiometry. All right? So this is a problem too. We are putting the content first before the chemical impact. Here's what's interesting. There's gold in plants. That's interesting. Why isn't that up here? What's this? You know, the history of bots. That's interesting. Why isn't that up here? Why am I not presenting those things first and then building the content around that? Why am I presenting the content first, force-feeding that content, and then making students try to learn the material for that? Okay, so that was my second problem, and that's something that I wanted